Does your model overpredict in A/B test? This video explains what happens in A/B test and what causes overprediction. This is one of our experiments. The treatment model overpredicts 8.49% on its own traffic. This video explains why the observed overprediction is fake. The model doesn't overpredict. It's a healthy model. In a typical training scenario, we feed the model with the training data. We get a model illustrated by the line passing through the training examples. When we run A/B test, we have different models serving traffic. The impressions come back into training data. Some of the training data come from model A, some from model B. Their distribution is different. The model is not able to fit both datasets. It passes through the middle. Let's look at the real example. This is the prediction error on the training data. It's close to 0. The model fits the training data well. During that time, we ran 50% versus 50% experiment. Each model contributes 1/2 of the training data. When we look at prediction error on each half of the training data, we can see the model overpredict on 1/2 of the data, while underpredict on the other half of the data. It verifies our hypothesis that the model lies in the middle and underfits on both subsets. Let's look at the impact of underfitting on inference. The chart on the top is the number of impressions served by this model. The chart on the bottom is its PCTR and CTR. In September, there was no A/B test. 100% of the requests were served by this model. All the training data come from one model. The model fits the training data very well. PCTR and CTR aligns perfectly. In October, we run a 50% versus 50% experiment. The number of impressions served by this model dropped by half. Each model contributes 1/2 of the training data. PCTR and CTR diverged. The model overpredicted because the model underfits on its own traffic. This is a more common scenario, 1% control versus 1% treatment. The remaining 98% of the unallocated traffic is also served by the control model. So 99% of the training data come from the control model. The model fits the control data while ignoring the treatment data as if it's outlier. As a result, the model severely underfits on the treatment data. This is the experiment we showed in the beginning of the video. It's a 1% versus 1% experiment. The treatment model overpredicts on its own traffic, and its PCTR is very close to the control CTR. We have the same observations at different times. It's because the treatment model fits the training data, and the training data is dominated by the control model. The treatment model observes CTR of 62%. Then it predicts 62%. Even if it overpredicts on its own traffic, it cannot correct itself because the signal is too weak. It's only 1% in the training data. It's ignored. The treatment model continuously predicts against the control CTR and continuously overpredict on its own traffic. Now we can see that overprediction is not the model's problem. It's just misled by the control data. If the treatment model is rolled out to production, its own traffic dominates the training data, the overprediction will disappear. So we only observe underfitting and overprediction when the treatment model is evaluated on the treatment traffic. It's not the right way to evaluate the treatment model. It should be evaluated on the control traffic. Ideally, it should be evaluated on the combined data of control and treatment. Here we propose pooled evaluation. This is used at Twitter ads prediction. We evenly sample from the global data. It makes sure distribution of the evaluation dataset aligns with that of training data. On this dataset, for each example, we request both models and get 2 predictions. We calculate the model metrics for both models. Since the model fits the whole training data, a better model should perform better on the evaluation dataset that is homogeneous with the training data. The conclusion is A/B test causes underfitting. The treatment model, especially when its traffic size is small, always overpredicts. The model quality and business metrics are not reliable in A/B test. The model should be evaluated on a dataset that is homogeneous with the training data. I'll leave the link to the slides in the comment. Welcome to comment.